Okay, so today we're going to take a look at 3-4. Okay, it's still solving equations. Now we've got variables on both sides. Okay, when you have variables on both sides, you have some choices in how you want to solve the problem. Okay, and both ways that you could choose might work. We'll try to pick the easiest way. Okay? So up until now, all the equations we solved only had letters on one side. This is an example of an equation with letters on both sides. This one we're just going to show you, and then we're going to go through some examples. So once I start numbering all the examples, that's the one I'm going to pick for the test. I'll pick one of those. Okay? Okay, so I just want you guys to listen to this. Okay, so in this equation, first thing you need to do is get all the variables on one side. Until we do that, we can't use the SAM method, right? We've got to get all the variables on one side. And then once we do that, this problem is going to be just like the ones you did yesterday. There's just that one extra step to start. Get all the variables on one side. Okay? In this one, you got a choice. You could put all the variables on the left, or you could put them on the right. I think one way is easier than the other. Okay? We'll try it maybe both ways. Okay? We'll see which way you think is easier.
Guys, want to go over the steps for this too, okay? Don't get too freaked out.
Okay, so we're going to do this one two ways. So this is example 1A. This one you want to have in your notes. Okay, method 1. Okay, to do method 1, let's put all the variables on the right side. Okay, let's try putting them on the right. So we get 6x minus 5 equals 2x minus 21. If we're going to put the variables on the right, we want to put that on the other side. Is this a positive 6x or a negative 6x? Kayla?
It's positive now, but you have to subtract it out to negative 6.
Right, it's positive now, but if we're going to move it to the other side, we have to subtract it and subtract it. It's gone from the left. What's on the left-hand side now?
Negative 5.
Just negative 5, yep. And now we've got 2x take away 6.
Negative 4x.
Very good, negative 4x. Now from here, it's just like a problem you did yesterday. Okay, so now we use the SAM method. There's no distributive property. There's no like terms. So what's my next step to get x alone? Again, I think you guys are going to prefer method 2, but if you can do method 1, method 2 will be easier. Savon?
Just add 21.
Good job. Add 21. Add 21. Okay, what's negative 5 plus 21?
16.
Yep, 16. Good job. Now we're almost done. Last step to get x alone. You got that multiplication. What do we do to undo multiplication? Division. What do we divide each side by?
4. Negative 4.
Negative 4. What does x come out to? What's 16 divided by negative 4? Okay, what's a positive divide by a negative?
Negative 4.
Negative 4. Okay, so method 1, we put all the variables on the right, we got negative 4. What do you think we're going to do in method 2? We're going to put all the variables on the left, yep. For this first problem, I'm doing it two ways. Every other problem today, we are not going to do it two ways. We're going to do it one way. Okay? But I just want to show you both ways to do the first one. Okay, let's put all the variables on the left. How would I put the 2x on the left-hand side?
You subtract out the 2.
We're going to subtract
Oh, the 2x.
2x, yep. So this time we're putting it on the other side.
You get positive 4x.
Positive 4x. Notice we got a positive 4 this time. If you can deal with positive numbers, that's probably an easier method. Then you don't have to worry about negatives. And this time we did. Maybe we can't always do that, but this time we did. Okay, so 6x minus 2x is 4x. What do I still have after the 4x? Still a negative 5, right? 2x minus 2x. What happens there? That cancels. That's gone. And we have minus 21.
Then you add the 5 to
Yep.
both sides.
And we add 5 to both sides. So we still have 4x on the left. What's negative 21
Negative 16.
plus 5? Everyone see negative 16? Okay, pretend like negative 21. You owe someone $21. Then you pay them back 5. Well, now you only owe them 16. Okay? Wait, what's my last step? Save on.
Divide by 4.
Divide by 4. Divide by 4. What's negative 16 divided by 4?
Negative 4.
Negative 4. What was the difference when we did method 1 or method 2 in the final answer?
Because we're arguing with negatives.
Did X do the first time?
Yeah, it just ended up with the variable on the other side, but did we get the same answer?
Yep.
Same answer. Okay, so when you're solving these problems, you have a choice. Put your variables on the left or put your variables on the right. It's up to you. You can get the correct answer either way. Okay? Here, why don't you guys try that one? Okay, try that one. Take a minute on your own, see if you can do it. I think there's definitely a certain side you should choose to put your variables on. Don't say it, but there's one side that's easier. Okay, just give it a shot, see what you can do. Okay, so our problem was 8 minus x. Let's see if what Kayla decides to do. Okay, so she's moving the numbers first. That's fine. I decided to move my letters first, but that's okay to do. So she put all her numbers on the left that don't have x's. That means she's going to put all the x's on the right.
Nice.
Shut up.
What is that? Is that
All right, let's take a look. So she added 4 on both sides. Okay, that's good. That canceled. 8 and 4 is 12. Perfect. Then she decided, okay, I got all my numbers on the left. I'm going to put all my letters on the right. So she added x, added x. Okay, when you add x to x, negative x cancels out. When you add 5x and 1x, now you have 6x. Okay? And now the last step, she add a 6 in front of the x, divide each side by 6. 6 is cancel. 12 divided by 6 is 2. That's perfect. Okay? So x is 2. Okay? Any question on that?
is that y?
The final answer, x equals 2. Yeah.
I'm trying to copy your
Okay.
terrible handwriting.
Okay, let's
I'm not studying.
try one more. Okay, try this one.
Are those Z's?
Yep, 7z. Remember, my 2's are going to be like that. That's a z. 7z minus 9 equals 3z plus 19. What's my first step going to be, Justin? What side should I put my variables on? Yeah, if we put all the variables on the left, it's going to stay positive. If you move the 7 to the right, it's going to become negative. So how do you move 3z to the other side?
Subtract it, that works.
Yep, that's a 2, that's a z. Someone just said it. Spencer,
You do negative 3 to 17.
you're going to subtract what?
3z from 7.
Perfect. You're going to subtract 3z from each side. Okay, when you subtract it here, it's gone. What's 7z Take away 3z. 4z. What else is still on the left? On the left. Minus 9. And now what's on the right still? That's your plus 19. Okay? Now this is just like a problem from yesterday. There's only variables on the left. So you got to put numbers without variables on the right. Okay? How do we move the negative 9 to the right? Laura? Plus 9. Very good. Plus 9. Okay. What's on the left-hand side now that we got rid of the negative 9?
4z.
Just 4z. 19 plus 9. 28. Now we're down to an even simpler problem. One step left. Okay. Clayton, what's my last step?
Divide by 4 on both sides.
Yep, divide by 4. Divide by 4.
7 equals C.
And how'd you get 7?
Because I know 4 plus 7 times 4 is 28.
Yeah, 28 divided by 4 gives you 7. Perfect. Z equals 7. Okay, any question on that? Okay, up until now, every problem that we've done on Monday, Tuesday, Wednesday, today, they've always had one answer. Sometimes when you try to solve a problem, you go to do it, and it can come out that there's no answer. Okay, when there's no answer, then we don't have to worry about an answer. There's no answer. Okay, so we're going to take a look at some problems that have no answers, and then some problems where there's more than one answer. In fact, anything could be an answer. Okay, so we'll take a look at those two special kinds of equations. Okay. Does everybody have example 1C? Okay, make sure you copy down the example and which number it is. Okay, because that could be the one on the test.
Oh, I would say 1A, 1B, and 1C.
Yep, I'll tell you which one I'm looking for.
We get to look at our notebooks.
Yep, you get your reference sheet.
Where? Oh, where? Whoa.
Okay, so this just summarizes what I just told you. Sometimes when you solve an equation, there's no solution to it. Okay, there's no answer. While some types of other equations, anything is an answer. Okay, we're going to look at a couple of each. We'll look at some where you can't solve it, and then some where everything is a solution. Okay, if you can't solve it, okay, I'll show you what's going to happen. But if you can solve it, the name of an equation that's always true, not just for one number, or 2 numbers, or 3 numbers, or 10 numbers, but no matter what number you pick, it's always true. That's called an identity. That's an equation that's always true, no matter what. You can pick any number you want, and it will be a solution. And I'll show you why. Okay, the equation has to be set up very special for that to happen. Okay, but we'll look at a couple. Okay, let's try this one. So negative 17 minus x equals 8x plus 6 minus 9x. Okay, what's our first step in the SAM method? We haven't done that step in this lesson yet, but yeah, simplify. We got it, simplify. What are the 2 steps under simplify? One of them is... Nope. What's our first step in the simplify
Hey
method?
guys, if you're not sure, have your sheet out so you can be looking at it. It's no good leaving your bag. See, like Matt has his out, that's good. That's what I want.
Matt, can you tell us? You got your sheet out?
First step in the SAM method.
Simplify.
Simplify, which includes...
Distribute.
Distribute, perfect. Okay, so is there distributive here?
No,
Nope, how do we know?
because there's no parentheses.
There's no parentheses. Okay, what's the second thing you have to do under simplify? Distribute and then
Combine.
combine like terms, right? Any like terms on the left? 8x.
Tyler, we did this one.
Okay, what else?
Yeah, I know, I don't remember it.
Minus, we should.
8x and,
Nine.
Plus.
nope, not 9x.
Negative 17.
No.
X.
Nope, there's no 17x in this problem.
Oh, wait,
What are
no.
we doing?
X.
Wait, what are we trying to
Same
combine?
side, combine like terms, same side. Negative 9x.
Oh,
Somebody said 9x, but that negative goes with the 9.
that was me.
So it's not positive 9x, it's negative. Okay, let's combine those. What's 8x? Take away 9x.
Negative 1.
Yep. You don't have to put the 1, negative 1 in front of the x, but I'm going to put it. Now we took a problem that was a little bit more complicated. Now we got it down to the type I was showing you before this, in example 1. Okay. Variables on each side. Let's put all our variables on the right. How do we move a negative 1x?
Add negative, or add 1x.
Add 1x. Add 1x. What's negative 1x plus x? Cancels. Uh-oh. Look over here. What's negative 1x plus x? Yeah, 0. So what happened to all the letters?
They're gone.
They're gone. When all your letters disappear, something special is going to happen. One of two things could happen. What's on the left-hand side now?
Negative 17.
Negative 17. What's on the right-hand side?
Positive 6.
Positive 6. Okay? When all your letters are gone, now you're done. There's nothing else to do. You have to look at this and figure out, what does this mean? Does negative 17 equal 6?
No.
No, that's not true. So do you think this means that there's no solution or anything is a solution?
Anything.
There's no solution. This is a false statement. There's no solution.
Are we going to have that on the test?
Yep, you could have one like that. Okay, so what this means is that there is no value for x that would ever solve this equation. This equation cannot be solved. There is no solution. It's impossible to solve it. Okay?
Nothing's impossible.
So again, the way you know that, all your letters are gone. So when all your letters are gone, that's when you got to start looking at it and be careful. Okay? If you have different numbers like we do here, that's no solution. Is negative 17 the same as 6? No.
Not.
That's not true. There's no solution. Okay? Let's try this one.
Guys, try this one on your own, see what you can do.
What?
Okay, give this one a shot. See what you can. Yeah, see what you can
Have
do.
you step,
Okay, what's our first step? If we're going to put all the x's on the same side, what do we have to do on both sides? Clayton?
Add negative 6.
Nope, not add negative 6.
Add positive.
Just add 6. Yep.
6x.
Where else?
Terry's trying
On the
to-
other side, too.
guys, hey, I know people want to answer, guys, raise your hand, we're getting a lot of, craziness.
What's
I'm
negative?
pumped up about math, but calm down.
What's negative 6x plus 6x?
All right, relax.
0. What about on the other side? Negative 6x plus 6x.
Cross them out.
They cross out. What's on the left-hand side now? 1? Right-hand side? 2. What does that mean? All the letters are gone. 1 equals 2. That's not true. No solution. Okay? What did I say the other kind of problem that could happen was? Besides not having
Any solution.
anything's a solution. Okay,
Isn't it
let's,
when it equals 1?
okay?
No, thank you. No, thank you.
I'll give you a hint to start. I'll give you a hint to
No,
start.
don't give me any hints. I don't
Kayla doesn't.
Close your eyes then and do the math.
Not say anything.
What's the first? Again, what's the first step? Raise your hand, please. I'm not gonna. Savon, what's the first step? Starts with an S. What's it called?
Oh, that's easy.
What's the first step?
Simplify.
Simplify, right? Simplify means two things. Distribute. Can we distribute?
No.
Heck no. What's the other one?
Hell.
What's the other one? Combined like terms. Sam, give me one, on this side of the equal sign, give me one set of like terms. And I want the sign that goes with it too. Negative 2x, right? And positive 9x. Awesome. Justin, give me another set of like terms with their signs too, please.
-4 and
Negative 3?
I said 4.
Okay. Remember, on this side of the equal sign.
-7.
Positive 1. And what's like positive 1?
Wait.
So combine the reds and combine the greens. With their signs. Don't be afraid to use a calculator.
Okay, so Mr. Roy found your like terms for
Guys,
you.
listen. Pay attention. I know it's late in the day. I understand. We're almost done. No notes tomorrow. Not at all. It's test day.
Well, that's really worse.
Okay,
Pay attention.
one thing, guys, I want to make clear. Okay, when you're combining like terms, okay, the CLT, that's not something you're doing on both sides. Okay, when we combine like terms, we're pretending the left-hand side doesn't even exist right now. And all we're going to do is combine what's circled in red, write it down, combine what's circled in green, write it down. Okay? What's negative 2x plus 9x? 7x. Very good. Negative 2 plus 9, that's your 7. And remember, it was an x, 7x. What's 1 minus 5? Negative 4. Very good. Okay. Now we have one step left. Let's put the x's on this side. How do you cancel out a positive 7x? Marcus?
-7x.
From where? So from here and where else?
The other side.
Where do I line it up? Yeah.
7x.
Line up those x's. What's 7x minus 7x? 0. Okay. What's 7x minus 7x on the other side? Uh-oh. What just happened? What happened to all the letters?
They all disappear.
Okay, when all your letters disappear, what could happen?
Magic trick.
What's one thing that can happen? We just did it in the last problem. You get no solution. Or let's look what we have here. Negative 4 on the left. What's on the right? Is that true?
Yeah.
That's true. Okay? So when you get a statement like this, same number on both sides, this is how I need you guys to write the answer. Okay? You probably haven't seen this before. All real numbers. That means that any number is a solution to this equation. So if you pick any number, it will always work. Does anybody have a question on that? Okay, so on the test tomorrow, if all your variables cancel out, you're checking for one of two things. Either no solution or all real numbers. Okay, all right, let's look at our last problem. Okay, we're going to look at it 2 steps. Okay, what I want to do with this problem is I want to set it up. I want to get it to the point where there's an equation. And then we're going to stop there. Okay, we're just going to set up the equation. It says Jane has $30 and she's saving $7 every week. Okay, she has $30 right now. and she's going to save $7 more every week. Okay, her friend Susan, she has $50 right now, but she can't quite save as much. She's only going to be able to save $3 a week. Okay? So what's going to happen eventually? Right now, Sue has more money, but she's not saving money as quickly. Okay, Jane has less money, but she's saving more money per week. Eventually, who's going to have more money? Because they're saving more money every week. Eventually, Jane is going to have more money than Sue. Okay? Even though she didn't start out with as much, she's saving more money every week. She's going to catch up. We want to find out, when do they catch up? Okay, when do they have the same amount of money? Okay, so we're just going to set up the equation, and then we'll leave it at that. How much money does Jane have to start? She has $30. Now she's going to be saving $7 every week. Is that going to give her more money or less money? What operation in math do we use when we're adding more? Plus. Now how do we represent $7 per week?
7W.
Sure, 7W. That's really good.
I don't know how many weeks she worked. Sorry, Marcus.
Okay? So if she works 1 week, that's $7. 2 weeks, another $7. That's 14. Okay? So this is for Jane. Now let's do the same thing for Susan. How much money does Susan start with? 50. How much money is she saving each week? So how would we represent that? 3W. Now we want to know when they have the same amount of money. What does that mean? We want to know when Jane and Sue are the same. When they what's a symbol in math that means the same? Equals. There's your equation. Right there. 30 plus 7W equals 50 plus 3W. Okay, now from here, you would solve it. Okay, we're going to leave that one maybe before the test tomorrow. That'll be a good one to start with and review.
One that said all real numbers, what example was that?
That was our last example.
Yeah.
3A. Okay, guys, so hold on 1 second. We're not done. Okay. So Mr. Roy is going to go over some of the problems for the test. Okay? So the homework tonight is going to be a worksheet. Okay, your homework tonight is going to be a worksheet. So the example that I want you guys to copy down for the test tomorrow is example 1C from today. Example 1C. Okay, and you already have the example from yesterday. Okay, guys, for homework tonight, this is going to be your worksheet that you're seeing right here.